big O notation is logarithmic, which is the O log n. Now here is that as the input size grows, or as the input size doubles, the algorithm takes one more step. Okay, let's say we have a book, a dictionary for instance. A dictionary have a page of 500. A dictionary have a page of 500. Now, we want to get the word E. Okay, let's say we want to get the word egg, for instance. Egg. Egg is in the word E. Okay. So now what we're going to do to that dictionary is that we'll open it into half. That's split it into 250 page. So now, if we put it into 250 page, maybe the one in the middle was a letter M. We'll throw away the right hand side and pick away the left hand side because that's the one closest to our goal, which is E. Then we bring it, we'll split it again, the 250 page into 2, which is going to be 125. We'll throw away the right hand side. Okay, let's say it landed at maybe H. We'll throw away the right hand side. We'll pick it again. We'll split it into 2. Let's say we split the 125 into 2, which is going to be like 62.5. Look, let's say luckily we landed at the word E when we split it into 2. So we just know that we just have to keep going to get the word egg. That's what O log n is all about. It talks about the size doubles, the algorithm takes one more step to achieve its goal. So as the input size doubles, let's say we have a book of 1000 for instance, we have to split it into 500 first, then into 250, then into 125, then into 62.5 in order to get the word egg. So that's already like about 5 to 6 steps it will take. That's what O log n is all about. Let me show you a few Python example on it. Example is in Python. Let's give it a function called bin research. Then we'll say our low equals to 0. Our low dot, let's comment out each deleted first element in the array and I should equal the length of the array minus 1. And this should be the last element. Is that what it is in the array? Do you know why we say length of array is minus 1? Because an array starts from an index 0. So if we're setting a normal box, it's going to count the number of elements that is there. But as an index 0, it's going to be less than 1. That's why we said minus 1. Then write our steps should be equal to 0. Our step is what? This is the number of guesses. So it will keep track of the number of guesses. Now let's introduce our while loop. Now say while our low, that's the first element in there, is less than equal to our I, the last element in the array. We'll now introduce a variable called the middle point, which gives you mid. Mid will now be bracket your low plus that's your first element plus your last element divided by 2. Then we'll now say our steps plus equal to 1 means it should add 1 to each steps as the input size doubles. It should add one more step to each of it. So while your this is equal to this, you want to say if your array mid, that's your mid is equal to our target. We'll now say that what should we say? It should return what mid and it should return the steps. And if our array mid is less than what the target, our low should be equal to what mid plus 1. That means it should move to the right to search for the targets. If the left hand side is less than the target, it should move to the right hand side to search for the target. Else our I equals to mid minus 1. That means it should move back to the left hand side to search for the what? For the target. So target. Now then we should return -1 and the steps. So now let's print out our array. Let's say our array is 1, 5, 0, 20, 90, 40, 55. And our target we're looking for is equals to let's say we're looking for 90 for instance. So now we'll now say your position on the steps will be equals to our function binary search the array target. So position binary search the target. So we'll now say target target found target found after after steps. So let's print it to check if code is working. Sorry, later. Now target found after 3 steps. So now this means that it takes 3 steps in order to find the target 90.